on, so you're able to type in some questions for me if you do. So hopefully that'll be working in the next few minutes. So good morning, everyone. You're very welcome to our lovely little masterclass here. Getting you ready for your 5th-year summer exams. So how do we go about that? Well, what we did was we decided to pick kind of 3 areas. And obviously, we've got an hour's chat here and then 15 minutes for questions at the end. But if you want me to do a few more questions and all that, just let me know. We can definitely cater that around for you. But the main thing is, how do we help you get ready for your summer exams? Well, obviously, we'll give you some pointers on topics, but of course, all different schools cover different topics. So this is more about approaches and tips and tricks to solving questions in general. And I just picked 3 topics to kind of illustrate that and the types of questions that are more popular and coming up, etc. So let's look at the first one, if that's all right. So I'm going to look at algebra and simultaneous equations. So there's kind of 2 varieties of simultaneous equations to look at. And we'll start off with the nice one because that's a good warm-up for everybody, which is obviously ideal. Early in the morning, let's kind of shake off the cobwebs. So these are my lovely little notes here. These will be shared with you, by the way, next week. So don't worry, just follow along and hopefully it'll all be good. You can obviously take any notes that you like, but do bear in mind you will get a copy of them and you'll have access to the recording too. So you won't miss out, just so you know. So I'll scroll on down there. Okay, so listen, a bit of text to read through. We won't go over the top reading through it. We'll definitely make an effort there. Oh, guys, I think the chat is working now, if I'm right. Yep, it looks like people can type. So if you have questions, I have the chat open there. Feel free to type in and let me know. I'll probably answer them more like at the end of a question, or if there might be a good question I want to spend time on, I might do it at the end of the class in general. That's all right. But you're very welcome to type in, and I'll be keeping an eye on it there. So when you're dealing with simultaneous equations, let's start with the first type. There's your 3-by simultaneous equations, okay? So that's where you have your 3 variables, typically your A, B, C, your X, Y, Z, whatever it might be, like that. Very familiar. Like I said, a little warm up for us today. The first thing you should always do is make sure you remove fractions if present. Now, some people don't do that, and that's, I respect that choice, but at the same time, I think you're letting yourself in for a more complicated style of question, and, why would you do that to yourselves? Totally unnecessary. And then what I would do is I'd number all equations 1, 2, and 3. It just helps to give you a bit of structure. That's all, so you can keep track of your work. Nothing major, but just gives you that little bit of structure there. And then you kind of go back to what's more like the junior cycle style of it. You pick 2 equations at a time. And when you pick your 2 equations at a time, you choose 1 variable. So let me just go from that point first of all with my question. There's no point in reading through everything. So we'll start off that. So here we go underneath. Here's my lovely little question here. So I've got A, B, C equals 2. I've got 2A plus 3B plus C is equal to 7. I've got A over 2, B over 6, C over 3 equals 2 over 3. So we can see right away there's a fraction one. So my alarm bell goes off and I'm like, right, I need to get rid of the fraction straight away. My opinion anyway. So first of all, I'm looking for the lowest common multiple of 2, 6, 3, and 3. Conveniently, it's already there. 6 is a common multiple of 2 and 6 and 3, so ideal. So I'm going to put a 6 in front of everything here, which means I'm multiplying every item on all sides by 6. So be careful with that. You want to make sure you multiply all items, not just one side, if that makes sense. You can just do one item on the left. You do every item on both sides by that 6. And as a result, then, let's see what we can come up with. So let's see. 6 divided by 2 is 3, so I end up with 3a. 6 divided by 6 is 1, so it's just minus b. 6 divided by 3 is 2, so it's plus 2c. And then lastly, 6 divided by 3 is 2, and 2 times 2 is 4. And then I have ones that I would say are way more accessible and way more approachable to you there. So then I number them 1, 2, and 3. And that's the starting point for sure. The next thing you do is pick a variable. Now, sometimes there's no wrong way to pick them. I'm not going to pick the variable a because I just think there's an a and there's a 2a and there's 3a. So there's just a couple of number combinations there I don't really want to deal with. But there'd be nothing wrong with picking a, it'd be absolutely fine. And b has pluses and minuses. The 3 is kind of annoying me there, so I wouldn't go with that. I'm just going to go with c because it's just plus c, and 2c. I just think it's the simplest one. There would be no wrong choice in this. Sometimes there's a poor choice, never a wrong choice, but sometimes there can be a poor choice. So I'm going to choose C as my variable, okay? So that's me gone through my first few steps there. Remove fractions, tick, number equations. Oh, did I actually number them after my talk? I did, phew. Pick 2 of the 3 equations and choose 1 variable. Right, well, I better pick 2 then. So I'm going to go with, let's see, I'll go 1 and 2. Right, so I'm going to pick equation 1 and equation 2. No, so haven't written them down yet though. Now, In both equations, ensure that your chosen variable, that's c for me, has the same coefficient. That means the number in front of c has to be the same, but one must be a plus, one must be a minus, therefore having opposite signs. And so I should adjust accordingly. So let's look at my situation so far. Oh, they're both plus 1c. So in that case, I'm going to multiply equation number 1 by minus 1. And the reason I do that is I get minus a minus b minus c equals minus 2. I'll leave equation 2 alone. I get 2a plus 3b plus c equals 7. And now I have a situation where I have minus 1c and plus 1c. Perfect. That's exactly what I wanted. Okay. Add your two equations. The resulting equation, it gets numbered 4. Cool. Off we go then. So add the two of these. So minus a plus 2a is just a. 3b minus b is plus 2b. And 7 minus 2 makes 5. And that's equation number 4 there. And that's it. So, pretty straightforward, but just a good to have, oh, that looks like a dodgy looking B there. Good to have a nice little approach to it there. Now, we're not done, obviously, there's more steps to read through, but after doing this, you kind of just are on repeat at this point. The most important thing to note is that once you picked your variable back on one of the earlier steps, you are locked into that variable. What I mean by that is, since we eliminated C to get equation 4, we must eliminate C again in order to get equation number 5. So just once you have your variable, that's the one you're kind of stuck working with there. It's not particularly a problem, but just to bear that in mind, I wouldn't start eliminating B or A at this point. It won't actually help you later on. So back we go, repeat from the beginning, choosing two different equations, but the same variable, and that'll give you equation number 5. Okay, well, let's do that then. Let's get equation number 5. Okay, off we go. So what will I pick? I will do equation 1 and equation 3. And okay, so that means I'm going to multiply, I'll multiply equation 1 by minus 2. That'll give me minus 2a minus 2b minus 2c equals minus 4. Equation 3 I'll leave alone. Let's see if I work that out okay. Lovely. And yet again, here I am. I have my plus 2c and my minus 2c. So my variable choice worked out for me. I'm going to be able to eliminate that. So I'm going to add again. Minus 2 plus 3 gives me 1a, or just a. Minus 2b minus 1b is minus 3b, like that. The c's minus 2c plus c, 2c, excuse me, nothing. And then 4 minus 4 is also nothing. So I'll write down 0 there. And that's equation number 5. And so that's your nice little kind of warm up so far, just to dust off some of those cobwebs. So once you have equation 4 and 5, you're going back to your junior cycle type of study on these. So let me go back to the notes there. Treat equations 4 and 5 as in section 4 above. That would be an earlier section in my notes there. And then find one variable. Okay, so off we go there. So we're going to do a plus 2b is equal to 5 and a minus 3b is equal to 0. And that's equation 4 and equation 5. Now, again, we have to just pick a variable that we want to eliminate. I think the a's are the easiest one by a long shot here. If you disagree with me, let me know, but I think it's a good choice. So I'm going to multiply this equation by minus 1. And I get minus a minus 2b equals minus 5. I'm leaving the fifth equation alone. And I end up with 0 for the a's, minus 5b equals minus 5. And therefore I get b is equal to 1. And I got one of my solutions. So hopefully that wasn't too stressful so far. Then you work your way slowly backwards. Sub your first answer into either equation 4 or 5. So don't go back to the start yet. So whichever one you want to pick there, I'm going to go with, which shall I go with? I'll go with equation 5. So I'm going to get a minus 3b is equal to 0. So a minus 3 times, I now know b is 1 is equal to 0. A minus 3 is equal to 0. So therefore a is equal to 3. Now I have my second of 3 solutions. Again, pretty happy. And then just pick one of the original equations once you have 2 solutions. And I'm going to pick the first one because it's by far the easiest one, like just 1a, 1b, 1c. Lovely. So a plus b plus c is equal to 2. So therefore 3 plus 1 plus c is equal to 2. 4 plus c is equal to 2. So c is therefore equal to minus 2. And that's that. So hopefully nothing too exciting there. Like I said, just a nice little warm-up to start off the class. popular topics, simultaneous equations, they come up a lot. And for you guys, you're more likely to encounter the next type, but that doesn't mean you won't encounter a 3 by like this. Like there's no reason you wouldn't. So it's just, a case of being aware of the method. I think the most important thing is to have good structure in your answer. What I would say as well, some advice when you're doing these questions is, you've a limited amount of time. So say this comes up typically in short sections, section A questions, and they're worth 30 marks. And this whole question that I just did, that wouldn't be worth 30 marks. It wouldn't be considered like, detailed or long enough, right? So as a result, you're talking maybe you have 7 or 8 minutes to do it as a result. So if you make a mistake or you think your answers are going a bit weird or you're not happy, I wouldn't advise you go back, excuse me, and try and fix it in the moment. So here's what I would advise. I'd advise you to work your way through it, following all the steps. So, get down to equation 4, get down to equation 5, combine those together, get 3 solutions for A, B, and C. You might think the numbers are crazy you got, and you're definitely wrong. But chances are, if you did get it wrong, it's probably only a small sign mistake or a small little calculation error. And fixing that might be the difference between getting, 12 or 14 out of 15 marks, say, which, is obviously better to get 15 out of 15, but it's still a good grade. Whereas the time it might take to find your error really could take away from other subjects or other topics later on. And I just don't think that's a good idea to do that to yourself. So I would definitely kind of see if you had time left over at the end and then go back and look for it. But if you follow the structure here, you're pretty much set. So if you think your answer is a bit weird, don't worry about it. If you follow the good structure, chances are there's only minor mistake or mistakes maybe here and there. So I definitely wouldn't panic about it, and I wouldn't spend the time trying to fix it. You'll spend double the time that you need to, and it's not really worth it. So that'd be just some advice there. So that was our little warm up there. So if there's anything you want to ask me, pop it into the chat. I'm happy to. But if not, we can obviously scroll on down. Lovely. Well, I'll keep my eye on it, like I said, anyway. So what I included here, and when the notes go out live on, I think you get them Monday or so, can't remember the exact dates. I just put other ones in here just to kind of show you different types, excuse me, that have come up over the years. So you can see here, like there's a good spread of the years they've been on. It's not a yearly feature for sure. It's considered like a nice question. The most recent one in 2022, I thought was lovely. And again, if you're making a summer exam, these are handy questions to put on. They show a bit of work. They show the students to study their methods. Always nice to do that. So, you may see one in your summer exams. The first one, though, I think is lovely from 2022. It's just they used big numbers, so you just would have your calculator handy and work through them, but the setup would be the same. Now, this might be a bit of audience participation, which could be, we'll see how that goes. Hopefully, you don't leave me with dead air here. Which variable would you pick in the 2022? Would you choose variable A to cancel out? Would you choose variable B to cancel out? Or would you choose variable C to cancel out? What would you go with? Okay, we've got one person in the chat so far. Lovely. Exactly. So there you go. They kind of were, you're absolutely all right. Well done, everybody. And all good choices. Now, listen, like I said, if you picked A or B, it's not wrong. You're just giving yourself a hard time. That's all. So, C was a great choice there. It's got 3 in front of all of them, and you just do -1, and, it'd be lovely. So, lovely practice question for you there. But the 2018 one, believe it or not, now give me a little thumbs up reaction. Would anyone feel intimidated by this one from 2018? I know some of my students have in the past. No, perfect. Okay. So the shortcut here in the 2018 one is a nice little fun one because what they've actually done is, excuse me, they've given you equation 1, 2, and 3. Okay, so I won't do the whole question now, we'll just talk you through it. There's 1, 2, and 3. But actually, if you look at equation 3, it's only got 2 variables in it. There's no y in it. So that was actually a help, believe it or not. Some people don't notice that, but there is no y present. Therefore, someone actually made a third equation that really could work as your fourth equation, because your fourth equation is the one you get with 2 variables in it. And so the third one in the list could easily do as equation number 4. The only thing is that means if you go with that route, which I would recommend, it's a huge time saver, which means you literally get to skip all of this over here, which is time you get back for other questions, so valuable time. And as a result, oh, my screen there didn't catch up, but there we go. Phew. Which as a result then frees you up to get equation number 5. The only thing is, because they have equation 4, 3/4, without a variable y, then you're locked in. If you go with that approach, that you must remove y to get equation 5. That's the only thing. So the variable choice, in my opinion, should be y to save you time. The variable choice of y. Okay. And then otherwise, it's just like my example. And then the one underneath, I mean, to be honest, is the most like my example. Well, that first one's a bit easier. But the one underneath has your lovely fractions in it. You get rid of the fraction first. So I would multiply everything in equation 2 by 2, and I'd multiply everything in equation 3 also by 2, and then I'd label 1, 2, 3, and I'd go through the question. So they're not very remarkable questions by any means, but, definitely questions of interest for sure. So hopefully that was all right. Again, the chat's open, so pop in any questions you like. Let's go into something maybe a little more interesting, a little more fun. But like I said, nice little warm up there for the first 15 minutes. So, on to page number 4. So linear and non-linear simultaneous equations, or definitely, maybe quadratic simultaneous equations, definitely not your typical style. Now, how do you recognize these? So I have 3 examples here. I've got one I'm going to work through, and I've got 2 from the exam papers there, and I've got some lovely steps you can go. You'll actually notice there's less steps. So one way there's less to think about, but people tend to not follow the steps too strictly here, and that can cause you a little bit of hassle, which, we like to avoid where possible. So what makes this one non-linear versus linear? Well, this is linear because it's all to the power of 1. So that makes it linear. Now, the one above, you might say, well, hold on, it's x to the power of 1 and y to the power of 1, so clearly that's linear too. And you're right about them being to the power of 1, but not about them being linear because there's multiplication with the variables involved, and that would make that non-linear. Okay, so it's good to identify which one's which. Now, sometimes you've got 2 sets which are non-linear, but, that's fine too. I'll just scroll down for a second, I'll come back into this one. So if you look at this one here, we have one here with squares in it. So that makes that one non-linear, and that's from your 2012 Leaving Cert. And therefore the one underneath, you can see it's all to the power of 1s. That makes that one linear. Same with this one here. We've got the squares in it from 2016. That's non-linear. And the one underneath is all to the power of 1. And therefore that one is linear. So I think that's the most important thing to begin the process. Identify the linear and the non-linear. Okay, so let me go through the steps then with you. It's only 5 steps. It's a lot shorter this time. A bit more work involved. Well, is there? Well, kind of in a way. A bit more complicated work. Okay, so you can be asked this question to do it algebraically, typically, and that's where we're going to look at the algebraic approach. Technically, you can do it on a graph too, but they usually would want you to do it algebraically, and that's really specified. So if you wish to solve for points of intersection without graphing, then we can use an algebraic approach below. So what we have here is 2 relations or functions, a linear and a nonlinear one. And we want to find out where they bump into each other or where they intersect, find their points of intersection. So I recommend you follow 5 steps. And if you talk yourself through the 5 steps, it should be pretty straightforward, hopefully. So look at the linear of the 2 equations, the one with no square, and isolate one of the variables or letters. So therefore, I'm going to write down now step number 1. I'm going to write down the linear one. So here's your 2 options, right? To do that, and I'd recommend one and not recommend the other. Sometimes there's no easy choice, unfortunately. So I could do 2x plus 2 equals y, and isolate y. Okay, so there's a tiny bit of lag there, I think. Or maybe more than a tiny bit. There we go. Okay, that was me isolating the y there. Or what you could do is, I could isolate the x and say 2x is equal to y minus 2, and then divide both sides by 2, and x is equal to y minus 2 over 2. And the only advice I can give you here is I would avoid at all costs, unless you must work with fractions, to not pick the one with the fraction in it, because it just creates a lot of work in step 2. But it's entirely up to you. There's no wrong choice, but there's definitely the harder choice. So the one on the right is the more difficult choice. The one on the left is the easier choice. So I'm going to go with this version here. And no one would expect you to write out both of them, just to be clear. Okay, so on to step number 2. Let's have a read. Substitute your now isolated expression into the nonlinear equation. Okay, cool. I can do that. So the nonlinear one I've already labeled up here. So I have x, y equals 4. So now I'm going to sub in y. Okay, so I do x 2x plus 2 instead of y equals 4. That's just me literally subbing in what I said y was equal to. I said y is equal to 2x plus 2, so I replace y with 2x plus 2. I used a bracket because x was multiplying y when they're stuck together. And so I want to make sure I'm showing that as well. Let's go on to step 3. Expand and simplify. Okay, so I can do that. Multiply out my brackets, everything to one side. I get 2x squared plus 2x. Bring over that 4, you get minus 4 is equal to 0. That was nice. Easy to expand and simplify that. I like to do a little thing. If I can simplify the whole expression in one go, I will. And what I mean by that is I'm going to divide everything by 2. Now let's be really crystal clear. That means you have to divide everything on both sides by 2. But luckily I have a 0 on the other side, so that's fine. So I end up with x squared plus x minus 2 equals 0. You do not need to do that if you don't want to. I just like to simplify it down. That's all. I like to work with smaller numbers when I can. So we've done step 1, we've done step 2, and we've done step 3 now. So step 4 is solve for your variable. In this case, the variable is x. Okay, so step 4 is to solve. Now, it's up to you how you'd like to solve. You can use array method, you can use the box method, you can use guide number, you can use factorizing brackets, or you can use the minus b formula. All legitimate methods, all work well to solve, so it's entirely up to you. So I'm just going to go through, because I recognize this one here. I'm going to use my brackets. Now I know to get x squared, I have to multiply x by x. And I know to get minus 2, I have to do, and it's either plus 2 minus 1 or minus 2 and plus 1. But because there's a plus 1 here, I know it's plus 2 and minus 1 there. So then when I solve, I get x equals minus 2, and I get x equals plus 1. Now, sometimes people get a little bit complacent in these questions and think that they're done there, which is a pity, because you're not. Step 5 is still there. Substitute in order to find the solutions for your second variable, because you have to find solutions for x and solutions for y. So therefore, we haven't got the y solutions yet. So don't forget about step 5. Sometimes it gets left out. Now, I usually use this here to help me because it's already in terms of y. So y is equal to 2x plus 2, like that. Now, as a result, all I have to do is pop in both of my x solutions into this, and I'll get both of my y solutions, hopefully anyway. So first of all, I'm going to do y is equal to 2, and then I'm going to use the minus 2. That's from here, just to be clear. Plus 2, and then I get minus 4 plus 2 is equal to minus 2. So I got a y solution now. Okay, so they match. So minus 2 and minus 2, nice and handy there. And then next, I'm going to do y is equal to 2, bracket 1 plus 2. Where am I getting that from? Down here. And then I'm going to do 2 plus 2 is equal to 4. And there's my answers. Now, if I was asked this from the point of view of find the points of intersection, now I didn't specify that exactly, but I did allude to it at the start. So if you're asked just to solve, that's absolutely fine the way I wrote it. But if you're asked to get the points of intersection, it would be worth your while to make sure you match up your points there and go, okay, I got minus 2, minus 2. That was from here and here, just to be clear. And then I got 1 and 4. And that came from here and here, like that. And that would be them then as points of intersection. If it didn't say points of intersection, you wouldn't have to do that step per se. It's entirely up to you. If it just said solve, the previous step is plenty. If it said points of intersection, I would do the 2 brackets then as well, just to show that you know what you did. Okay. So again, hop in any questions into the chat. Well, that was my little one there. I'll look at the next 2 now, just to give you some guides through the exam style ones. They don't really change too much either. And I do want to talk to you about a question, actually, my 5th years who are getting ready for their summer exam next week. We're practicing yesterday, and it was an interesting little one, and they kind of didn't realize what they were doing at a certain point. So I thought it was interesting to talk about today. Okay, there's page number 5. Again, with the first one here, we've already identified which one's the linear and the nonlinear. So in this case, you work with the linear for step 1 and isolate one of the letters. So again, chime in now. What do you think would be the best choice in the 2012 question to isolate? Would you be in fan of isolating A or would you isolate B? And I'm talking about in this one here. Which would be the best choice, do you think? Absolutely. A is by far the best choice there, just because the B one will leave you with a fraction. And then if you do that, you just follow the steps through. Now, do bear in mind, though, and I'll just show you just to be clear on this, to make sure everyone's comfortable with it. We isolate A, that's step 1. Okay, so A is equal to minus 2B minus 1. And step 2 is to substitute, but you must substitute it in for all the A's you see. So what I mean by that is you have to sub it in for the first one. Okay, but also for this next a here, oh, times b, sorry, and then plus the b squared equals the 3. So just bear that in mind, like it does have to be every one of that variable. So all those a's I substituted in my new isolated a into. So just to bear that in mind. Okay, and then you just follow the steps through. Excuse me. The 2016 one there is next. Now, I must say, horrible. So I'll ask you the question, but there's no right answer, unfortunately. I won't even ask you. There's no good one to isolate because they both result in a fraction. Now, I do want to point out one thing when that happens. Now, listen, it's kind of like a worst case scenario situation, in fairness. I've never kind of seen one that involved quite the same amount of work. It's not that it's impossible by any means, it's just that it's like, it's hassle. So I will go through this one just a little bit. I won't do the whole thing, but I want to show you kind of like important thing to note here. So you pick your linear one, right? And I'll do 2x is equal to minus 1 minus 3y, and then divide both by 2. And I get x is equal to minus 1 minus 3y over 2, right? So that's, step one. Grand. Fine. I know I'm in for it now because I have to have a fraction, right? There was no way to avoid it. It was either that or over 3 with the y. So, it's a lose-lose. Step two is the substitute in. Okay, so I'll do that. That's okay. I think we can all manage to do the substitution in squared plus then minus 1 minus 3y over 2 times y plus 2y squared equals 4. Okay, so again, not the worst, but this is what sometimes happens to people. They get a little bit lost in the sauce on the next step. So I'll just go through it. So you square out the top part. So, squaring out, it's up to you how you do it. Do 2 brackets, do it in your head, do it to the side, whatever way you work. I like to do this little kind of thing I say to myself. I square term 1, so minus 1 squared is 1. Twice term 1 by term 2. So this is term 1, this is term 2. So that gives me plus 6y and square term 2, which is 9y squared. Now here's what people forget, and this is why I want to talk about it, is don't forget to square the number on the bottom as well, which makes it 4. And then here you have plus and brackets minus y minus 3y squared over 2 plus 2y squared equals to 4. So like not bad, but here's the thing. Next, how do you handle it? And this is why I want to stop at this point now, because that's step number 3 there is the expansion and simplifying. So to keep going with the simplifying, I would then multiply each item here by the highest, by the common multiple. Yeah, no, common multiple, sorry, of each of those numbers. And so it should be a 4 in front of everything across the board again. And I think that'll eliminate the fraction bit. So at least when you do it this way, you end up removing any fractions pretty early on. And again, like I said, at least it's not the worst, but it's not the best either. So you can see there, I had to work with the fractions only for 2 lines maximum. It could be worse. It's not ideal, but it definitely could be worse for sure. So just to kind of guide you through it, don't always panic, but eliminate the fraction, in my opinion anyway, as quickly as possible. And you'll give yourself an easier time, which is kind of, what we're all about. We want to make it right, simple, well illustrated, but also easy on ourselves. That was just some tips and tricks there for you on those, just to handle kind of the worst case scenarios. I'll show you real quickly the one my class were doing yesterday, just that they lost their the kind of track of what they're doing briefly. So they had this situation here. They'd done some lovely function work for me, which I was delighted with. I forget the end number. It was like 710 or something. There's a decimal on it anyway, so we'll just do it roughly for now. And then they had this one here, and it was like 830, roughly. Okay. So they had these two, they'd done the function work, they got this, and the question said find P and A. Now, they both happen to be nonlinear, so that's why they were a bit thrown. They were like, oh, these are different. But again, they did spot there was 2 things they didn't know, which was simultaneous equations, but they didn't know the best approach. So let's see. One person went and did this. Okay, and then one person went and did this. And I mean, they're both not wrong, but I'll ask you to tell me which one you think is the easiest approach. So they were following the step 1, that A looks terrible. So which one do you think is the right one? The first one I did, isolating P, or the second one I did, isolating A cubed? What'd you go for? Hmm. One's better than the other. The second one, okay, cool. First one, oh, we have finally we've split the room. Oh, we've split again. Okay, great. This is fun. Second, first. Ooh, okay, hotly contested. Right, you seem pretty split on this actually. Just slightly more going for the first method. Great. So I'm glad I mentioned it then. This is great. Okay, cool. So I personally, this is me, like I said, neither is wrong. But if you go with this method here, you're going to have to go a is equal to the cubed root of 710 over p. Now, right away, I'm kind of going like, ugh, hassle. Not impossible, but hassle. And it's up to you. This is step one. So you pick whichever one you like. And then step two is to sub it into the other one. This is much nicer to sub in, to be honest. It is. Because if you pop it in here, you get 710 over a cubed times a5 is equal to 830. a5 divided by a cubed is just a squared. So you have 710 a squared is equal to 830. It didn't end up being quite as scary as it could have been. If you go down the cubed root part, because it's power of 5 and then the cubed, they don't match as well if you go the root way. Now, you can make it work. Don't get me wrong. I'm not saying it's a no. I just think you're giving yourself a harder time. So always go with the simpler option, as in p to the power of 1 is simpler than a to the power of 3. So just some advice for you there. And then they were just dividing by 710 and solving. So again, I'm just giving you some tips and tricks and approaches there. That was all. So that was just like a little extra question from my class yesterday. So we happened to do it yesterday. And I thought, cool, I'm doing simultaneous equations with you guys, so why not bring the knowledge and share it around? But it was good. That was a nicely hotly debated one. I always kind of think that's more interesting, which is fun. Okay, so there's just some approaches for you to use. I covered just some basics in algebra there as well, like, removing fractions, solving equations, how to handle your simultaneous, that kind of thing. Just being careful with the equal sign. Just covered a few of the basics, like I said. Right, there's two other things I want to do. And that's to look at trigonometry and to look at the line. So I kind of spent half the class doing something from paper one, which is your lovely algebra, which are two types of simultaneous. And then I want to spend the other half of the class doing something from paper two, which would be your practical trigonometry and your coordinate geometry of the line. And if there's extra time, there's a little thing I want to do at the end. If there's not, then I'm not too worried about it. We'll just see how we run. Kind of put in more rather than less. So on to page number 6, if that's okay. Don't forget this is all recorded, so if I'm scrolling too fast, you can let me know, I can go back, but also you'll get a copy of it, so don't worry, and you get a copy of the notes too. So practical trigonometry. Okay, practical trigonometry is what involves the rules. So I always tell my students, listen, in your trigonometry kit, for when you're doing practical problems, you have 5 tools. And the 5 tools are some you're really familiar with from junior cycle and some that are new to you from senior cycle. So now, if you haven't done this before, first of all, it might just seem like a little bit new, which is fair, of course, but they're actually lovely little rules and really handy. So the first 2 rules you come across, which I think we're all familiar with from junior cycle, are the rules, I should say, for right-angled triangles only. So the 2 rules I'm about to discuss exclusively relate to right-angled triangles. And they are the theorem of Pythagoras and SOHCAHTOA sine cos tan, the 3 trigonometric ratios. So they exist in all their lovely glory. And I've just put in the notes here, a little bit of chat about each one. I won't go through each one now because it's just going to be a lot of me reading. And the whole point was me to give you the tips and tricks for how to practically solve some questions. So that's why I want to focus on that, if that's all right. So they work exclusively for right-angled triangles, just to bear that in mind, okay? But as senior cycle higher level students, you have to work with, and for the ordinary level students too, but this is focused on higher level, you have to work on also non-right angled triangles. So the next 3 rules we're going to discuss, if you've seen them before, you'll know where I'm going with this, work for all types of triangles, right and non-right angled, whereas these 2 exclusively only for right-angled triangles. And you need to have that in the back of your head. It's probably the most important thing to kind of bear in mind as you go through it. So then, that's just me now. These are all my little bits of just theory notes on SOHCAHTOA and Pythagoras. Like, there's not really, I don't want to bore you with the theory, to be honest. It's just to remind you of how they work. So you'll get those in the notes. Here I look at the area of a triangle. So this little formula here is in your tables book on page number 16. It's lovely there. And it helps you to find the area of a triangle, whether it's right angled or non-right angled. So it's very useful in all situations. But why do I want to stop and talk about this one? But just momentarily, because what I want you to remember is, if you have seen it, and if you haven't, I want you to know then, that when you have these lovely formulas, any lowercase or small letters represent sides. Okay? That A and that B represent sides of the triangle. And any capital letters or uppercase letters represent angles. So this C here represents the angle capital C. So just kind of to note that, like lowercase exclusively for sides and uppercase then would be for angles. So just important. Next, we have the sine rule. So the sine rule helps you find sides or angles. So therefore, it's like SOHCAHTOA, except it works in all triangles. So that's why it's unlike SOHCAHTOA. So SOHCAHTOA will help you find sides or angles in right angle triangles. Sine rule will help you find sides or angles in all types of triangles. That's what the sine rule is useful for. And there's the formula. It's on page 16 of the tables book. It's lovely. I did give a little note here about the ambiguous case. It just was a popular topic years ago and hadn't been seen in the leading cert for a while. And then 2024 gave an ambiguous case question. And it just means that sometimes it's not clear how the triangle could be drawn. So just to give you a side note, just for your benefit, because it was popular last year, when there are two sides and an angle not in between those sides, and particularly if the diagram is not given to you. So last year they wrote, hey, there's this side, and this angle. And then obviously I've been doing this for a while. So when I read it, I was like, oh, well, of course, this is going to be ambiguous because it's two sides and an angle. And it looks like this, where the angle is not in the middle. And therefore it can be drawn two different ways, with an acute angle or an obtuse angle. And therefore they asked in the question, what are the two possible answers? So it's just something to note there. We're not going to spend the whole next, 25 plus minutes doing that. So just to bear that in mind. Again, it's just in the notes for your benefit. And the last rule is the cosine rule. It also works with It also works with sides and angles. And you can see here we've got the lowercase and the uppercase letters again. So there's your 5 tools that we're going to use. And to be honest, in practical trigonometry is a huge topic. And again, if I was making a summer exam, I would make sure that I have a practical trig question on it because, it takes up a good bit of space. The students have to show their knowledge and show their work and all that. So what I want to do is focus now on how to go about solving these problems. Okay, so have a little kind of list. You might have gotten this by now. I love a list and bullet points and all that. So that, works for me. And, usually if you kind of follow it, it won't go too badly for you. Okay. So the goal in your practical trigonometry is to use any of the above rules. So just to remind you, Pythagoras, SOHCAHTOA, area, sine rule, cosine rule. It's just the 5. To help with your problem solving, try and look at the problem and then ask yourself, are there any common sides? So for example, if you can see two small triangles, do they have a side in common? So I'm going to highlight that in yellow. Are there any common sides? Yes, indeed, I see a common side here. Okay, and just note that to yourself, right? Usually a good way to start. Now, next is which triangle do I have the most information about? Okay, the left one or the right one. So just by a small amount, it's the left one because I happen to know a side length in the left one. So I'm going to mark that in there. But that's my part one. It's the one I have the most information about. Are there any simple calculations I can do? And by simple calculations, I mean something that, someone who's just started studying about triangles, maybe in first or second year, would be able to do. So for example, that you'd be able to work out this angle by doing 180 minus 131. So what are you going to get? Oh, 31, not 131. Silly me. 31. So you're going to get 149. There we go. That's a simple calculation we can do. Next up here, I can do then 180 minus 149 and minus 30, minus 18. Ooh, 18 is the other angle there. We take out both of those. So 180, just make sure I don't mess it up. 149 minus 18. Okay, so that's 13 degrees at the top. Lovely. And then the other one here I can do for this one, 180 minus 90, because it's a right angle, minus 31. So 180 minus 90 minus 31, and I get 59. So that was my first things to do. Common sides, which triangle do you know the most about, and then mark in the simple calculations. There's usually 1 or 2 simple calculations you can always do. And you've put lots of stuff on the page, and you've actually got some pretty filled in work here. Now, the next one is, which rule should you use to find the common side? So just to be clear, we've already decided we're working with the left triangle because it's got the most information about it. So I'm working with that purple triangle there. But the goal is then make sure you find your common side because, it's the one that helps you link the two triangles and you want to definitely create that link as best as you can. So the first thing I go is, can I use Pythagoras on the purple triangle? And the answer is no. There's no right angle. So scratch that. Can I use SOHCAHTOA on the purple triangle? Absolutely not, because it's not right angled. Great, I'm down to 3. Can I use the area of a triangle formula? I could, but no one asked me to find the area, and there's no mention of area, so not now anyway. Maybe later, but I don't think so. And then I'm down to, is the sine rule or cosine rule? So I'll just start with sine rule, see if it works. If it works, great. If it's not, I'll try cosine rule. So you just kind of break it down like that. So I'm looking for the common side. So I always call the side I'm looking for lowercase a. And again, I've decided to go with the sine rule for now. Ooh, and just to see if it works. It should do, I think, but if I'm not, I'll go with the cosine rule. So I always label what I want, small a. So there we go. And the angle directly opposite it is capital A. That means 18 is now capital A. Then whichever other side you know, call lowercase b. And the angle opposite that is uppercase, then b. So as long as you can fill in 3 out of 4 parts in your sine rule, you're good to go. So I have a over sine, capital A I labeled as 18, and then b is, lowercase b I should say, is 20, over sine then of capital B, which is sine 13, like that. Couple of things to note here. You're almost done. However, you're going to need your calculator, and it's all in degrees. So if you've done trigonometry, you'll know there's 2 types of angle measure, degrees and radians. So you want to make sure you are working in degrees because the question's given in degrees. So just do check if you're not. Otherwise, you're almost good to go. So what I would do is there, I want to get a by itself. So I'm going to multiply both sides by sine 18, like that. So I can cross that out, which is great. And then I just do a is equal to 20 sine 18 over sine 13 in my calculator. I did do it earlier to save me time. Yeah, I got 27.5. Okay. So I got there 27.5 for this length here, 27.5. Now, I didn't answer the question yet, but trust me, this is the best approach to do it. I can guarantee you that. So did I find the common side? Done. Lovely. And then how can I find what I'm actually being asked to find here? So then you go back to square one again. So now I'm going to work on the yellow triangle, which I'm going to highlight now in yellow, and help me find h. So it's up to you. You pick your rule. Will I get Pythagoras? It's a right angle triangle, so I could do Pythagoras, but I need to know 2 sides and I don't know 1. So unfortunately, Pythagoras is out. But it's a right angle, so I could use SOHCAHTOA. So I'm going to use SOHCAHTOA. Now, I don't know about you guys, but my fifth years just tend to not use SOHCAHTOA and just always go for sine rule, which I don't disagree with because you can use sine rule in both right and non-right angle. So I think in their minds, they're just like, hey, it's a one-stop shop. It'll do it all for me. So I don't mind it, but SOHCAHTOA is just like a little bit quicker, to be honest, like a little bit. TOA is my choice here. And this is my angle of interest. So I'm going to go with 31. I could have used 59. I'm just going with 31 because it's there. And what you do then is, very nicely, you just go across from 31. And that means that the side across from it is the opposite, like that. So the opposite is h. And then I go across from my right angle, and I hit 27.5. And the side that's opposite the right angle is called the hypotenuse. So I want the opposite, and I know the hypotenuse. So I'm looking for the one that contains O and H. So it's sine. And that's just marked in SOHCAHTOA. That's why I write SOHCAHTOA on the page. So SOH. So sine then of my angle of interest 31 is equal to the opposite, which in this case is h, over the hypotenuse, which is 27.5. Again, I'm just going to multiply both sides by 27.5 to remove my fraction. Therefore, h is equal to 27.5 sine 31. And then I did calculator, yeah, I did it now. Yeah, I did. Perfect. And that's equal to 14.2. Just checking if I actually did the calculation out. There we go. That's my approach to that, how I like to do it. So I like to just get students to work their way through them and go, okay, simple calculations, common sides. Just start with that. You don't have to jump into a calculation right away. And go through your list. 1, 2, 3, 4, 5. Pythagoras, SOHCAHTOA, area, sine, cosine, every time. And it's really nice and friendly after that. So hopefully that was okay. Let me know in the chat if there's any questions. We'll look at some exam questions underneath then. just to kind of show you how that applies across the board. And I'll start picking your brains then if that's all right for one or two of them, just for fun. Could you use the 59 degrees? Absolutely, 100%. You could have easily used that. And that would just mean, just to be clear though, that this would be the opposite if you had used that. Therefore, that would be the adjacent. And so as a result, it would be cos 59 is equal to h over 27.5. So you just would adjust your ratio. Instead of using sine, you'd use cos because it was the adjacent, depending on how you labeled it. So as long as you're comfortable with that, absolutely. And again, like I said, my fifth year is just religiously. Would the sine not turn into sine minus when you brought it over? The sine turned into sine minus. So just tell me, am I right in saying that you mean here? Is that correct? So I know the location you're talking about, just since I'm not messing you around on the answer. Nope. Oh, what part then? Down. When else did I bring sine over? I don't think I did anywhere else, did I? Do. 27.5. Oh, when I brought so I multiplied both sides by 27.5. So the 27.5 went over to the sine 31. So the sine didn't go anywhere. But I think I can answer your question if that helps. Because the only time you use sine minus 1, so we actually call it sine inverse, is when you're trying to find the angle. So if the angle is unknown, you would use sine, cos, or tan inverse, so power minus 1. But we knew the angle here, which was 31. So there'd be definitely no need to use inverse in this instance. So hope that answered your question. Not let me know. Easier if the mics were on, but would they accept the answer if the decimal is one off? So they'd have to specify in the question. This is just one of my own little questions. Again, I just use it as an exemplar. Oh, I did say correct one decimal place. Oh, cool. Would they accept the one decimal off? Like they'd accept it, but you would be deducted a point at least for that. Now, unless sometimes, depending on which rule you use, actually there can be a slight decimal difference and they account for that in the marking. So that's okay, if that makes sense. But no, if it was just a kind of rounding error, you would like lose a point. Not too bad, but you know. Okay, cool. They were great questions. Thanks, everyone. I always like the questions. They kind of keep me on my toes. How much marks would you earn if you got up to the fourth line? One, two. So the marks earned depend very much on the mark scheme for the year. So the marking scheme comes and goes, as in like they'll always kind of go like, hey, if there's four steps, maybe it's like, you know, low partial, mid partial, high partial, full mark, steps one, two, three, four. And then other times they're more specific, excuse me, and they're like, okay, finds the common side four. And that's just it. Like, you know, there's no way to it. So it kind of depends on the year, if I'm being honest. So I couldn't tell you like a set in stone approach to how they do that. So the markings always get adjusted depending. So the fourth line though would be, is that the 27.5? Is that what you mean with the fourth line? Yeah, I'd say mid partial. So you're talking like out of 10, maybe six. Just because it really isn't fully completed. It's you know a decent bit off, I suppose. It's nearly same amount of work again. Hey, cool. Loving all the questions. This is fun. Means you're all listening to it. It's nice. So here's one from 2020. No one actually technically sat it because it was 2020, but still a very nice question. I love to use it as an example here. So the question would like you to find how far, excuse me, f is from the base of g. So this is what's being asked. Okay, this is the final result there. They want that little side there. Sorry, there's a slight delay again with my little question mark. There we go. So they want that one there. So again, the first thing I would say to my students is, you know, where's the common side? And I spot one right away over here. Okay, that's a common side. There's other common sides, but that's just a common side for sure. And then I also think we could do a lot of simple calculations. I think we could fill in, no, I'm not going to do it all again. I think we could fill in that angle. I think we could fill in that one. I think we can fill in that one because we know the other two. Then before we can fill in that one because it's a straight line. And we can fill in that one. So actually every angle can be filled in, which is ideal. Oh, sorry, the delay there is making me talk but not show you. So we can definitely fill in all of them, which is great. And then you should aim to find the common side. Now again, let's have a look. I'm going to highlight this one in purple. Okay, I'll let that just sync up for a second. There we go. That's the one I know the most about, only by the tiniest amount because I know the base is 6 meters. And therefore I would work on that one and find the common side. It won't give me the final answer. Like I won't get the question mark straight off the bat, but that's why these questions are kind of more interesting because there's more work involved. So I'm looking to find the common side first of all. So again, just ask yourself. Now, you guys tell me. Give me a thumbs up. I won't ask you to comment. You can if you want in the chat, but who would use Pythagoras on the purple triangle? Okay. Who would use Sakatoa on the purple triangle? Okay. Now, anyone who thinks they should use any of those, just bear in mind for 1 second, that purple triangle does not contain a 90-degree angle. So no Pythagoras, no Sakatoa. So make sure that's kind of in the background all the time. If there's no right angle there, don't do it. Definitely not. Okay. You could do area, but no one asked you to do. And therefore, because of the no right angle, then it automatically defaults yet again to sine rule. So be careful now. So anyone who thought about Pythagoras or Sakatoa, I totally get why you thought about it. It makes sense in my mind, but it just won't work because there's no 90-degree. So once you find your common side, so it's very like my example earlier. I've highlighted now the yellow triangle, or at least I think I have. It's about to sync up, I think. It's half highlighted. Come on, sync up. Anyway, so it's about to pop in there, I'd imagine anyway. So what you're looking for there is, in that one there is we're trying to find the question mark. Now, the idea is we'll have done the common side and worked to it. So again, look at the yellow triangle. I don't think there's a 90-degree angle in there. So no Pythagoras, no Sakatoa, yet again. And then you're down to your sine rule or cosine rule. So it's very similar approaches. That's all right. And again, pop in questions if you have them for me. There's this lovely one underneath now, as I scroll down from 2021. Now, this one's simpler. There's not two triangles, so there's no common side. So you can skip that part. And you can also skip the part about which triangle has more information because there's only one triangle. But there are simple calculations to be done, which you could definitely do yourselves, no bother to you. But also, can you use Pythagoras on that triangle? Because it does say find BC. That's a side. Who thinks now you can use Pythagoras on that? Wonderful. No one said it because you're right. You can't use it. There's no right angle. And same for Sokotoa. Doesn't work. So again, you're down to your sine rule. You can kind of see the pattern here. They love to get you to answer those questions. There's one more on the next page to chat about. That's all right. Excuse me, from 2023. I love this one. Okay, so I'm going to do some highlighting. You may have noticed, if none of you have met me before, I do enjoy a highlighter to kind of illustrate the questions there. Okay. Oh, the purple one's lagging a bit. But anyway. So as you can see, well, no, as you can't see, but as you can see, there's a common side or to O. But the question wants us to find O to H. So you can see there, I can tell a common side because the highlighting works in the sense of one side gets highlighted twice. Now the question wants you to find O to H, which is over there. Yet again, you can fill in every angle in advance, which I recommend. And then you can identify the common side, which we just chatted about. And then you can figure out, okay, which triangle should I work with? So who thinks we should work with the top triangle or who thinks we should work with the bottom triangle? So yellow or purple? Which one do you think we should work with first? And remember, it's the one you know the most about. Absolutely. There you go. And the goal is, you're all spot on. And the goal is work with the one you know the most about to find the common side. That'll lead you to this one. Yet again, look at the purple one. No Pythagoras, no Sakatoa for the purple one because it's not right angled. So again, you jump straight into sine rule. If it doesn't work, try cosine. However, the yellow one has a right angle. So you have free rein to use whichever rule you feel is appropriate to find that side when you're ready. So then you just follow that little approach and it does stack up a lot of times with the different questions. Which is kind of nice, hopefully. Okay, so that was just me taking you through then my approach to practical trigonometry. And again, that situation there has triangle coming off the page. So just kind of leaned in slightly there to three-dimensional ones as well. That was all. So again, just some tips and tricks for you there. If you follow that approach, I tend to find it works quite well. And it breaks these questions down and makes them a little less intimidating. So they can be a bit overwhelming. There's a lot going on, different shapes like that. So if you're not a fan of highlighters, I apologize. I am. And so therefore. How do you know when to use sine or cosine rule? Okay, there are some hard and fast ways to know. So that's a great question. My general thing is, it's up to you. So I'll tell you now in a second, just to be clear. But I would always just try sine rule. And if you can fill in three out of four things, use the sine rule. Um, and if not, then use the cosine rule. That's genuinely how I teach it to my students. But if you want a hard and fast way to do it, so number one, do they always give diagrams of the triangles? Now, Michael, or Michelle, sorry, Paddy, I'll answer that in 1 second. Don't worry, I won't ignore you. So for the previous question there, with the sine rule, then it's always handy if you know a side, an angle, and another side or angle. That's usually how you identify it's the sine rule there. For the cosine rule, it works best when there's three sides and no angles. That's usually then what I'd recommend for that one. But typically I just go and try sine, and then if it doesn't work, do cosine. You won't lose much time because you'll have done your labeling like A and B and capital A, capital B. So you're really not going to lose out. If that makes sense. And so, Michelle, to answer your question, they will almost always give you, excuse me, a diagram. And if they don't, alarm bells, suspicion, because last year in 2024 they did not give a diagram for one of the trait questions, and it was why when they went, oh, here's like two sides and an angle, and then you could do a rough sketch yourself, which I always encourage you to do. If there's no diagram, make one. And it was a case of like, oh, wait a minute, there's two ways you could draw this. So they were leaning into the ambiguous case for the sine rule, which is where it could be an obtuse or an acute angle. And therefore you'd have two answers. So if you don't see a diagram, they're testing your theory knowledge. They're going, are you well studied up on something like the ambiguous case? And, that's how they're really trying to differentiate between those, H1, H2 students. Just because, if you know everything and can do the calculations, you're going to get a good grade. That kind of is it. That's easier said than done, of course. But that's the goal. That's how they test you on that. Hope I answered both of those coherently enough. Don't know if I tended to ramble there a little bit. Cool. Well, there's no follow-ups, but our follow-ups, let me know. I like the questions. So, gang, our last little thing I was going to look at today is something then that, again, I pick topics that I just know a lot of people do from their revision course and crash courses we do in the institute, that these are topics people tend to have done in fifth year. And I just picked, like I said, kind of three. I was going to do some calculus, but then not everyone does calculus in fifth year. So I kind of thought, like, okay. So I didn't go with that in the end. So I went to coordinate geometry, the line. And again, I just gave you a little kind of cheat sheet of the theory here, as in like midpoint and distance. Listen, they're grand. They're from junior cycle. They're in the tables book. Like, nothing of note there. They've got the lovely formulas if you want. Slope of a line, I just kind of brought in some terminology there for you, like the gradient is another way to say it. And you have your formula. Don't forget about rise over run. Don't forget about parallel and perpendicular and those words and what they mean. That's all. A positive slope means it's increasing. A negative slope means it's decreasing. Just, an overview from your junior cycle again. Nothing new, but just always good to know how to tell perpendicular versus parallel slopes. Then I did some translations and area of a triangle, because sometimes people forget this. It came up in 2023 that they just said, like, here's 3 points, get the area of this triangle. And people forgot they had to do a translation on it. And if you don't know what a translation is, don't worry. I'm going to sneak one in later at the end. But what I really want to focus on here is the equation of a line at the bottom of this page here, because there's two equations of a line, and it's kind of up to you which one to use and why. And I just like to discuss this sometimes with people because it's sometimes the easiest thing in the world, but people get totally freaked out by it. I'm sure you're kind of wondering, like, why? And I want to illustrate that with two kind of questions. So the equation, the first one there, the y minus y one, is used when you have a point and a slope and someone says, would you go get the equation of the line? Like, that's typically the one you use. Not exclusively, but 90% of the time would be. The y equals mx plus c is if you're asked to write it in that form, that's fine. If you know particular information about it, you could use that form. But realistically, that's the one you use when you'd like to read information from your equation, like m being the slope and c being the y-intercept. It's a handy way to sketch. So I'm going to illustrate that now in a second. That's kind of what I want to focus on. But if there's time, I think I'll have a little bit of time. I'll do some translation work as well. Just a little bit. It depends on the questions. I'm happy either way. There's just some notes on how to get the x-intercept, the y-intercept, that kind of thing. This is the one that kind of gets me the most for people. And I notice it like comes up like this will come up in most people's leaving cert somewhere because they do tend to ask you to show points around a line or on a function or in a circle or belong to an equation or is a solution or is a root. They always ask it in multiple sections, and it just means to substitute. People tend to forget to substitute, or they kind of lose their nerve on what to do with that. So just to bear that in mind, it comes up a lot. So this is what we have. If we have time, I'll do this at the end, but I'll just do the equation work now, if that's all right. I want to talk about it in the end. I'll just put in all the theory on it, just so you'd have like the full contents. But I wanted to focus on the equation of a line, just because it's sometimes overlooked as being really easy, which is great. We love when things are easy, but it can suddenly get a bit twisted into being a bit more difficult. So let's see how we handle that. That's all. So do the basic one. No issue with that. I'm sure you have no problem with that. So find the equation of t, and here's the line t, which has 2 points on it. So listen, pretty inoffensive question. I don't think you're going to have any trouble with it. I'll go through it, but there's a reason. Promise. Okay, so to get the equation of a line, you need it in this form here. Y minus y1 equals m times x minus x1. That's grand. Close that bracket. Lovely. So the first thing you need is your slope, which is m. So y2 minus y1 over x2 minus x1. And it's not given in the question. So we have to go calculate ourselves. Right. X1, Y1, X2, Y2. So we end up with 4 minus 9 over X2, which is minus 7, minus 3. So I believe we end up with 5 over 4. If I'm wrong, no, I'm not. Right. That's fine. That's your slope. Lovely. Now, once you have a point and a slope, you're good to use the equation of a line. So y minus, and again, I have it labeled here, y1, so I'll just do it 9, is equal to the slope, 5 over 4, and then x minus x1, like that. Okay, so again, just to kind of show you like full circle moment, we still have to get rid of fractions here, so I'm going to put a 4 here and a 4 here. And that way, everything on both sides is being multiplied by 4. So I have 4y minus 36 is equal to, now multiplying and dividing by 4 means you get to just cross it out, which is great. And then that's 5x, and then minus 1 is plus 3, so plus 15. Everything over to one side, 0 is equal to 5x minus 4y, and plus, and that's going to be 451, I believe. Did I do that right? I did, good. Okay, so that's part A done there. Grant, let's say you're all professionals at that. No bother to you, I'd imagine, right? Part B, investigate if the point 2 minus 6 lies on the line t. Okay, let's sub it in. 0 is equal to 5 bracket, and there's x and there's y. So 2 minus 4 times minus 6 plus 51. Pop that into your calculator, so you get 10 plus 24 plus 51, which is 85. And I think it's fair to say 85 is not the same as 0. So therefore, 2 minus 6 does not lie on t. There you go. Commonly asked, though, all the time, in all different sections, so worth your while knowing it, for sure. Okay, so what am I on about developing that? Or why would we develop it, or how would we develop it? Because the question underneath is almost the same question. It's actually a bit easier there. So we have the line t contains the point a0 and 0b. Great. Find the slope of t. Right, so again, don't lose your nerve. x1, y1, x2, y2. Part A there. y2 minus y1 over x2 minus x1 is how you get your slope, which we're going to call m, of course. And you sub in. So b minus 0 over 0 minus a is equal to b over minus a, or just minus b over a. So the sign always goes with the numerator. So just to bear that in mind. And that's that. That's how you do that one there. But then it does say find the equation of t. So again, we've already labeled everything. We have our slope, we have our x1, y1, so we're good to go. So it's y minus y1, which is 0, is equal to your slope minus b over a, and then x minus x1, which is a. Multiply both sides by a. Ooh, it's jumping around over there. Multiply both sides by a, so you get rid of your fraction. That's lovely. So I have a times y is ay, and a times 0 is just nothing, so I'm going to leave that blank. Equals. Multiply and divide by a, so nothing happens. You get minus bx, and then plus ab. Everything over to one side. Now I'm going to bring everything to the left this time because typically you have a positive coefficient for x, typically. So bx plus ay and minus ab equals to 0. Again, looks a bit more intimidating, I think, or maybe it doesn't to you, but just to kind of show you that. Now, why would I go through doing something as simple as the equation of a line? Let's have a look now at some exam questions. Did the company now they don't tend to state it in the question, so good point. But they usually write in the form like they say, "Oh, give your answer in the form ax plus by plus c equals 0," and they don't specify that a should be positive. But then all the time when you see the marking scheme, they go with the version of it like that. So is it a huge error? No, but it's just kind of like one of those things where it's like, oh yeah, it's usually go where the x is positive typically. So I would try and do that if you could, unless you're writing in the form y equals mx plus c, in which case that's just fine as well. You can do that instead. But yeah, I would, and I'd always encourage my students to do so. Okay, so I'm looking down then if the page moves with me to my next page here. I just have some exam questions there. Sorry, it's a tiny bit stalled. Um, there we go, it moved. Lovely. So this 2018 question there. Listen, look, hot off the press as well. Hot off the press a couple of years ago, but verify that that's on M. So, you just need to know I should substitute into M. Do I get 0 on both sides? Yes or no? Grand. Okay. 2016, we have this lovely point, this lovely slope, and they literally said get the equation in that form there. There you go again, another equation of the line. So they're not pushing you too much so far anyway. Now, then we get into this one here, where we have this lovely question, and we have the line P makes an intercept on the x-axis and the y-axis of so on and so on. Find the equation of P and show it can be written like that. So what you do is you get your lovely answer. So I think, is this very similar to what I did? Let's scroll up for a moment. Yeah, it is actually. Okay, so I got bx plus ay equals to ab, and they wrote it like this instead. Now, all that you had to do in the last kind of stages of it was just be comfortable to go, okay, I need to get 1x. That means I divide that by AB and AB and AB there. That's all. It was just one little extension. Otherwise, it's almost the same as my question there. So you have x over A plus y over B is equal to 1. Yeah, lovely. It was the same question, basically. That was that one there. So just kind of testing your nerve there. So again, you can see as the questions get a bit later on, they want you to work more with letters. That's kind of the general idea. The part B to that was the line L has a slope of M and a point of 6, 0. Find the equation of L. And they literally just wanted you to work with the letter M instead. So just, you couldn't get the slope. You had to just use the letter. So actually it was really short. So you just like subbed into your equation, used M for M, and off you went. Like it was pretty nice. And then page 19, I think that's my last kind of main one. Yeah, because I had the other ones here. Perfect, yeah. So page 19, or 19, is my last official page, unless there's a bit of dead air at the end, and I'll show you something else. And it has the 2022 question there. And it says the line L has a slope of M and contains the point Q, and find the coordinates of where it cuts the y-axis. So in order to do that, you need to have the equation of the line, first of all. Okay. And if you look at the notes where you cut the x-axis, or y-axis, that means where x equals 0. So you'd sub in x equals 0. So that's the idea. They're just trying to get you to show you confidence of working with letters there. So they started off, pre kind of 2020, 2021, giving you more numbers. And since then, they've been more into the whole, well, no, we're going to get you to work with the variables now instead. That's kind of that. So everyone, we've got plenty of time left for questions if questions are something that's on your mind. Would the recording of this class be up in Moodle? Now, it won't be in Moodle, but it will be shared with everyone who's on the course, so you will get it. But I don't think it's through Moodle. They didn't tell me in the email how it's shared with you, but it will be shared with you if that's any help. But don't we have time left, by the way? So, I mean, obviously, if you can all, I'd encourage you not to leave because I can do something else. But technically, the last few minutes are meant to be for questions. What's the big difference? Now, Ella, it's a great question. The big difference between paper one and paper two is the topics that are on it. So if you're talking about paper one, we are talking about algebra, logs, indices, functions, calculus, sequences and series, complex numbers, financial maths. Paper 2, trigonometry, statistics. I can't spell. Statistics, probability, coordinate geometry, line and circle in there, and what's the other one I was going to say? Synthetic geometry. There we go. That's a rough overview there. So that'll be your major things, the topics that come up. Could you explain the ambiguous case again? Sure thing. So, Isabella, when you have it, it's usually when they don't give you a diagram and they give you these measurements. So say, for example, I said to you, like, hey, like, here's a triangle with like 10, and here's a triangle with 5, and this angle down here is, I don't know, 40, right? So, oh, sorry, the diagram's been really slow again. It'll show up here there. Is that for every year or can it change? That's the structure for most years. Now, the one thing that moves around a little bit, financial maths can sometimes hop around between paper 1 and paper 2. So that can happen a little bit. But overall, that's roughly it. They sometimes overlap topics like calculus and trigonometry are strongly linked. So you might see a little bit of overlap there, but usually that's where they tend to live mostly. Learning off the formulas, interesting. Like a lot of formulas don't need to be learned off, if that makes sense, because you have your tables book. So are you thinking of any ones in particular? None are coming to mind. Like there's not too much. Now proofs are a pain. In synthetic geometry. So don't get me wrong with that. And there's sorry, I'll do the ambiguous case first. Oh, I'll tell you that. That's an easy one. Olivia. So that could be written like that, or drawn like that, I should say. But then also, then to connect it up here. So there's one example of it. And as we can see, yeah, that's an acute angle there. Whereas I could also do the exact same situation here. And then suddenly it's an obtuse angle. So that's why the ambiguous case exists, because there's two ways to draw those, for sure. So that's the ambiguous case. And then I wouldn't draw both. I would just do the work and then figure out then if it's not clear, I would do the two answers for the angle. Now, make sure I'm answering all the questions in order. So let's see. How would I recommend learning off formulas? So Claire, I just wasn't entirely sure that aren't given. If anything come to mind, let me know. I'm trying to think of which ones aren't really given. Most of them tend to be in the tables book. Now, maybe I'm just being silly and forgetting something. Now let's answer the questions in order. How long do you recommend spending each question? Olivia, great question. So in the Leaving Cert, there's section A questions, which are worth 30 marks each, and you're looking at 15 minutes per question for the section A's. And then you're looking at doubling that to 30 minutes for the section B's. So that's how it works. So a section B question would have multiple parts, like maybe 5 or 6. A section A tends to have roughly 3 parts. And they're clearly defined into each section. So that would be that one there. Okay, next one. How would you recommend studying for maths? And then what's the best way to study for maths? So I'm looking for H1. Cool, I can do that. Oh, induction. Well done. You forgot. I forgot induction. Thank you. Hold on. Looking for H1. So to study maths, here's how I recommend it to all my students. Number 1. Okay, don't study what you know. If you know you can do a simultaneous equation, then studying it over and over again really doesn't prove anything other than I know this, which you already knew you knew. So I wouldn't do that. But obviously practice is good, but not overdoing it. Number 2, a H1, H2, or a higher scoring student has to show that they know a lot. And knowing a lot and doing a lot are different things. So, for example, you need to know certain kind of theory points, certain points of interest. You need to show that you've learned off your proofs. You need to show off all that. If you're looking for H1, you kind of have to be bulletproof in knowing everything. And then on top of that, you need to do everything as well. Whereas someone maybe more H3 or H4 can do a lot, but mightn't be as up to date on their theory. Or vice versa. They could be really well studied, but find it more complicated to do. Like that. So let's make sure I'm answering all the questions. Next one, what paper would induction turn up on? Induction tends to be on paper 1. So I should add that in there for induction. There we go. I knew I was forgetting one of the paper 1 ones. How would you recommend learning proofs? Honestly, learn off the diagrams first for the proofs, Ella. And once you have the diagrams down, then learn off the statements, like as in what you're trying to prove and any of the constructions. Start like that, because they'll get you loads of marks. So bear that in mind. And then you can just learn off the third step, which is the bit that's annoying. But to be honest, if you practice those questions, like in the textbooks, like using the questions that apply to those proofs, you'll actually learn them off really well then, because you're like, oh, it's that side over that side, it's that side over the stuff like that. So I do diagram and then constructions. And once you have those bulletproof, then start to add the other bits. I wouldn't try and learn it all in one go. I think that's just a nightmare. You get Dahi exactly, and that one even is a bit, it's handy enough as multiplying your brackets. So Claire, like the ones in statistics, for example, mutually exclusive events. Oh yeah, oh God, you're right, Claire. Sorry. So from the one probability ones, yeah, the set theory at the end, yeah, you do kind of have to learn that off now. Like say, for example, when I do it with my students, the last page is always like, this is the summary of all the little theory points you need to know. I wouldn't call them proofs as that's any help. I'd call them theory points. Because you're not really doing a formal proof with those. You're just more so, oh, how do I show events are independent? Well, I show the probability of A, but the probability, like that. So it's more so like that's showing what you know. That's the idea there. In your opinion, what would be the best way to approach a difficult trig word problem, and how many marks on average do mathematical word problems carry on the paper? So that's a good point. So the way I would approach it is, and not to fabulous, I would do exactly what I did there. I would be like, okay, like look at the diagram. What's the common side? What can I fill in? What are the simple things I can do? Always start from there and then break down your rules, right angled versus non-right angled. And that's how I do them. And the way they're marked honestly depends on the year and how they come up. So I couldn't give you a hard and fast number on it. But section B tends to be more the wordy problems. So, typically half the paper is section B for both papers. Can you do a coordinate geometry question with real life scenarios? As in, can I or would one come up? I don't really understand that question. Apologies there. So just let maybe rephrase if that's okay. Grace, are there any topics that you think come up more often than others? To be honest, there's a good spread, but the heavy hitters on paper one, so this is for Grace now. The heavy hitters on paper one are your algebra and your calculus. They're the big heavy hitters. They're the ones I'm like to start with those. And paper two, you're talking about those two. So that's how I would split it up, and then I start working my way down from there. That aren't given centroid formula and all might need to be learned off. The centroid formula, I wouldn't learn off the centroid formula. It's also in the tables book. So no, you don't need to learn the centroid formula. Can you do a question on proof by induction? As in, would you like me to do one now? Is that what you meant? I wasn't sure about that. In the 2016 statistical question, could you multiply by 2 immediately to get rid of a fraction? Or no, the 2016 one, let me scroll up. That's why I don't give you a fab off answer. The 2016, oh, sorry, that's lower down. No, because if you multiply by 2, you undo your isolation. So no, you wouldn't. Would it be possible to teach myself the full 6-year course over the summer using the book? I am going to say no to that personally. Now, maybe you're a very high achieving, very academic student who can interpret the textbooks very well, and perhaps that's true. I would imagine if there was a textbook out there that people could read and do themselves, I'd probably be out of a job. So usually you kind of need the good book as the grounding you, and then the teacher to kind of like break it down and explain it. Hey, next one. Could you also show us how to prove that square root of 2 is an irrational number? So again, that's a formal proof. So again, like, not to fob you off or anything, but just with a formal proof, it's one of those things of like you probably have one and it's just to go through the steps. So I can happily show you, but it's just I'd imagine you probably worked your way through it. Same with the induction question. It's just a case of, they exist and you have to do the setup of them, if that makes sense. So I can do one with you, of course, but just to bear that in mind, just going to get through the questions. Are trig questions with 3D shapes common? Yeah, they are. Yeah, absolutely. And they definitely are. Do the difference equations from applied ever creep into sets, sequences and series like the home? No, not really, to be honest, Dahi, they don't. Can you go over one? Yes, can you go a proof by induction question? Sure, I can in a bit. Now we're just kind of getting short on time, and I'd need to go look for one. But sure, would you recommend doing a couple of chapters during the summer? It depends where you're at. Like say, I'm running a course in the institute over the summer for transitioning from fifth into sixth year. So I'm covering like the big fifth year topics. So you could do something like that, but obviously you can look over stuff yourselves as well. If you feel like you're behind, if you're on top of things, nope, I think you're good to go. Do you have any math book recommendations for more practice? No, in the institute we make all our own notes, so I don't use any maths books. So honestly, Karen, no, I don't use one myself. Could you verbally go over to Moivers there, please? Verbally go over to Moivers. Oh my God, you want me to lose the room? Everyone will go to sleep. Okay, so there's three things I've been asked about. So with the route to being irrational, I would honestly just look up that either in your book or and follow the steps on it. It's not that I'm fobbing you off there. So that would be how I'd recommend that. It's a formal proof, like it's not very exciting in any means. For induction, I suppose I'm kind of wondering there, like with the induction question, because I don't know if many of you would have done induction by now. Like where is the issue with your induction question, I suppose? Tell me that. And then for the De Moivre's theorem, are you okay with writing things in polar form? That's really the core of it. Because De Moivre's is easy, polar form's the hard part. Well, if you're good with polar form, then I can explain that in a couple of seconds to you. That's grand. So if you've gotten your form, okay, r cos pi over 6 plus I sine pi over 6, that's v, and then they ask you to work out v cubed, then you would just simply put your cubed there, and then you apply it to the number in front as a cubed, and then you multiply it. Well, that should be a bracket, my apologies. Then you multiply the angles instead. So you get 3 pi over 6. So if you're in polar form, that's the hard part. The De Moivre's is actually the nice bit. After that, what chapter is this De Moivre's? I know, right? I knew when someone asked, I was like, no, it's too early in the year. De Moivre's is from complex numbers. So if you haven't done it yet, definitely don't sweat it. Like it's a short question every year. It's lovely, but like as in you'll be grand when you get to it. Like there might just be a little gap here and there, but that's really it. That's from complex numbers. It's just funny to ask it. De Moivre's already. Who made you do that in 50? Um, cool. Okay, I think I almost got around to everything. I think I did. If I skipped you, let me know. Sorry, would you mind scrolling down to the different topics? Yeah, of course. Sorry, I forgot I didn't go back to that page, so no worries. And don't forget, it's all recorded. So there was the induction question. Is the only thing I think I didn't. Sorry, yeah, cool. Did I miss anyone else's questions? That was fun though. You kept me going with the questions. I liked it. Questions are my favorite things. It means I get to talk more. Mm. Okay, cool. So there's the induction to chat about briefly, but I'm not entirely sure what you want me to do with, as in, I think you want me to do a whole question on induction, but maybe you have one in mind. Maybe let me know if that's the case. I can't remember who it was now. I've lost it. Lost track of you in the questions. Apologies. Uh, um, so there you go. Yeah. Oh, okay, gang. Are done with the questions then? Let me know. We're kind of just at time there. I didn't really get to go over. I did include a question on proof by induction. How you would solve it. Yeah, do you have one in mind to just off the top of your head? Can go look for one, but just, a whole one. Okay, cool. That takes a bit of time now, but yeah, sure. Okay. Right, in terms of solving basic quadratics, do you have any other ways than minus b? To be honest, if you're struggling with solving quadratics, use the minus b. That's my genuine advice. Make sure you do that, Claire, to be honest, because if you're not, can you look one up? Can you look up for one? Thank you so much. If while I'm answering these, if you might maybe just kind of have one that you had in mind, that'd be great. You could let me know it. And that I can go through it, be no problem at all. Or I can find one in a minute. Yeah, I would just go with minus b, to be honest. Cool. Okay, gang. I'm going to do an induction question. It's not very exciting. But we can obviously feel free to hang around. If you haven't done induction yet, I wouldn't worry about it. Then it'd be fine to do when you're kind of working through something there. But otherwise, I think I might kind of end it there if that's all right. If you have any more questions, I'll go for it. We can run. Like we're over now by 7, 8 minutes, but that's fine. Where will we be able to find the recordings? Now, all I was told is they will be sent to the students and so will the notes. So I guess on the email address you signed up with, I'd say. If I check there, I don't think there's going to be a Moodle page for it. So I think you'll just be sent a link to the recording. I believe. That's what I was told anyway. No worries at all. Okay, well, if you have any other questions, let me know. I'll go through an induction question now in a second, but otherwise, you're free to go. You're very good turning up. I hope that was helpful for you and you enjoyed it. Thanks for all the questions. They were fun. Enjoyed it. Introduction. Okay, Grant. I like it. Okay, I'll have to look that up quickly then. Perfect. Okay, cool. Listen, everyone, you're free to go. I'm going to stop the recording and I'll just do this little induction question there. Oh, thanks, Mel. I appreciate that. That's very sweet. Thanks. It's always hard when I can't see people or they can't talk to me. I'm like, is that going well or not? So I appreciate it. Thank you. That was very kind. Cool. Well, listen, You have all been amazing. If you want to stay around to watch the induction question, then first of all, wow, fair play. But if not, you're free to go and enjoy. I'll stop the recording now. And thank you for all those messages. You're very welcome. It was lovely. Very nice to meet you all. If I see you around again, come up and say hi to me. Introduce yourselves. Say like I was in your class.